Greetings and welcome to the Chapter 2 lecture. This is your third lecture for the class. This week I'm going to upload Chapter 2 and then also Chapter 4 lecture. Chapter 2 covering substance addictions and Chapter 4 covering ethics. Addiction is defined as an addictive process that has many components, behavioral elements, and may or may not involve physical dependence. We're going to look at, throughout the semester, the terminology that's used and how we diagnose and the terminology and how we describe the process of addiction with our clients and within the field of substance abuse counseling. The neurobiology and physiology of addiction, there's no single biological factor. However, the brain does change with addiction. The ad campaign from the 1970s and 80s, which showed a cracked egg in a frying pan, this is your brain and this is your brain on drugs. Well, that really is an appropriate description of addiction. Brain cells are rapid fired, or the neurological damage that's done can be seen as equal to the damage that where you can see someone who describes it as being fried, or the neural pathways that are overworked or that are depleted as a result of substance use. There are a lot of things that happen. The brain is wired so that if you do something that you like, that you're going to do it again, which is why eating, other type of pleasure type things, sex, food, enjoyment of family, all that type of stuff are considered to be factors in helping someone to become addicted to certain things. Dopamine-containing neurons relay messages about pleasure through their nerve fibers and nerve cells in the limbic system structure, and this is called the nucleus accumbens. Still, other fibers reach to a related part of the front region of the cerebral cortex. If you do like this and point like this from the side and the front, then that's the pleasure center of the brain. And then also the pleasure circuit, which is known as the mesolimbic dopamine system, spans the survival-oriented brainstem and the emotional limbic system and the frontal cerebral cortex. What does this mean? This means that the reward pathway, that these areas are key, of brain key to addictive cycle, and here's where the picture here gives you a good example of what this looks like. Where you look at the map here, and this is something that's going to be important to teach to your clients and to be able to do in CD education, for them to be able to see why the effects that addiction has on the brain, why it has those effects. The reward circuit is the ventral tegmental area, or the VTA, the nucleus accumbens, and the prefrontal cortex. This is called reward, which is pleasure. It's so powerful. It's a biological force to survival. If we didn't eat, we wouldn't be able to survive. We need sleep, rest, sex for not just for reproduction, but certainly it's important for reproduction, but also for our physical needs. The brain is wired so that you tend to do something that's rewarding or pleasurable again, and you'll learn some more of those principles in behavior modification. Eating, all of these things are important things that you cannot live without. If you look here, you can see the reward pathway, the prefrontal cortex, the nucleus accumbens, and the ventral tegmental area. It starts with the ventral tegmental area, goes through the nucleus accumbens, and then the prefrontal cortex. The nerve cells within the brain are called neurons, or nerve cells, and neurotransmission. Neurons is 100 billion nerve cells. Neurotransmitters include dopamine, GABA, which is gamma-aminic butyric acid, and glutamate. And these are all natural nerve cells and neurotransmission that's natural in the brain, and neuroreceptors. What happens when and we're going to look a little further, is what happens when, and here on this slide we see when cocaine enters the brain, it blocks the dopamine transporter from pumping dopamine back into the transmitting neuron, and therefore, well, let me see if I can size this back up real quick, and therefore the dopamine will leave too much of the neuron flooding the synapses with dopamine. This intensifies and prolongs the stimulation of receiving neurons in the brain's pleasure circuits, thus a cocaine high. As you can see here, what happens is too much dopamine, the cocaine blocks the reuptake, and then the high comes from the natural hormones. And then eventually what we see with addiction here on this slide is that eventually there is going to be a depletion of those chemicals, which causes which causes the person to want to do more drugs or alcohol. Cocaine has other actions on the brain in addition to activating the brain's reward circuitry. Using brain imaging technologies such as what we see here, which is a PET scan, allows us to see which regions are most affected by the addiction. Glucose is the main energy source for the brain. When brain regions are more active, they will use more glucose, and when they're less active, they use less. And that's why the red color here shows the highest level of glucose utilization. Yellow shows the areas where the utilization, and the blue indicated the least. The right scan here is someone who is on cocaine. The neurobiology here of loss of control and compulsive use. Frontal areas of the brain are the anterior cingulated cortex, or the ACC, and the orbitofrontal cortex, or the OFC. Cortico-basal ganglia network, which is the dorsal striatum, which is your spinal cord. And then brain is physically damaged and less capable of learning. Then this is going to be a dysfunction. This is frontal areas dysfunction that also appears apparent in obsessive compulsive disorder. Effects of alcohol on the brain. Studies suggest that 50% of alcoholics have some degree of brain damage, more damage to the right hemisphere, and volume shrinkage as a result of long-term alcohol use. And this is a significant disruption of the neurogenesis. Different types of tolerance that happens from addiction. Tolerance is neuroadaptation, genetic influences, metabolic tolerance, pharmacodynamic tolerance, where one drug is switched or has a similar tolerance is built. If someone takes alcohol and then takes tranquilizers, they're both depressants, and so they would have a similar acting function. High tolerance leads to a higher risk of dependency, and then withdrawal can be life-threatening. Metabolic tolerance is when the body becomes more efficient in processing and eliminating a mood-altering substance, and pharmacodynamic tolerance is when the central nervous system is less impaired by the drug. Long-term use causes there to be less effect to the system. Some substances of addiction that we'll talk about throughout this semester are depressants, alcohol, stimulants, cocaine, cannabinoids, marijuana, hallucinogens, ecstasy, and opiates, hydrocodone. I give you one of each, and there are many different types of substances in each area. When we look at depressants, they suppress the central nervous system. There's alcohol, and then other sedative hypnotic drugs like your muscle relaxers and such as soma. Your alcohol, which is considered ethanol proof, 7% of alcohol and ethanol is equal 14 proof. 151 proof rum equals, and you can do the math there and figure out what percentage of ethanol is in that. The mood-altering effects are present within 20 minutes. What happens is alcohol is metabolized by the liver as a toxin, which is why someone is considered to be intoxicated. When we look at blood alcohol concentration levels in the state of Texas, 0.08 is considered to be impaired beyond driving, but we see that people are impaired and sometimes even intoxicated depending on their body weight and such, around 0.06. Someone who's double the legal limit, 0.16, would be considered to be severely impaired. We look at sedative and hypnotic drugs, benzodiazepine, aka tranquilizers, the PAMs, diazepam, alprazepam, which is Valium, and Xanax. These are high risk for abuse and addiction, and women are at risk. Findings show women are 55% more likely to be prescribed benzodiazepines than men, and that's from NIDA, National Institute on Drug Abuse, 2005. We look at barbiturates, which are not as prevalent now as they were in the 70s. It's amobarbital and secobarbital, Nembutal, They're very lethal and have a lethal potential. Non-barbiturates, which are quaaludes. I'm sure if you've watched any movies from the 70s or 80s, you've heard of what are called quaaludes. Stimulants can include tobacco or nicotine, ephedrine, which many thins were famous for truckers using them. Those were taken off the market because of ephedrine, and ephedrine has been removed because it is a regular part of the manufacturing of methamphetamines. But we also see amphetamines listed here, which can be prescribed still today by doctors. Form of amphetamine for learning with those with ADHD is Ritalin, and then also cocaine as a stimulant, which also has the form of crack cocaine. Ephedrine and amphetamines, amphetamine-like medications. There was a legal ban that came out in 2004 for ephedrine because of the side effects, as well as methamphetamine speed, or the use of ephedrine to manufacture methamphetamine. Methamphetamine, it can be oral, taken by putting it in a paper towel or a capsule, and swallowed, snorted, smoked, or injected. Non-pharmaceutical, ice and cat, methamphetamine, lower cost, and there's many impurities. Well, here on the streets in Texas, it's known as crank, and it's whenever ice is made, what happens is the byproduct is the cheaper, or anytime that they may be missing one part of the cooking process, then they'll come up with this not clear like ice, not this clear form of methamphetamine, but a byproduct, or a not as purified product, which is crank, which causes when you see someone who's really tweaked out, someone who's having major bad trip off meth, in most cases it's going to be crank. Amphetamine-like medications, Ritalin, which is methylphenidate, and then it's prescribed for ADHD. Cocaine, the epidemic came in the late 1800s and early 1900s. There was a time when cocaine could be bought off of a medicine cart and also ordered from catalogs. Crack cocaine, it became about as a cheap, smokable, concentrated form of cocaine. Both of the cocaine has an increased amount of physical dependence. Tolerance to the drug is built, and then severe withdrawal because of what we looked at with the brain scans earlier. It has a strong potential for abuse. Marijuana, cannabinoids, of course, there's a lot of debate in our society of the true harmful effects of marijuana. What we can agree upon is the physical effects that include reduced lung capacity, lowered testosterone levels, racing pulse, decreased muscle strength, brain changes, also prolonged use in adolescence associated with risk of psychosis, and also reducing normal growth patterns in adolescence because of the natural brain chemistry changes that are going on when you introduce these drugs in adolescence. It can be growth stunting, especially when we talk about marijuana mixed with any type of PCP or any other type of embalming fluid. Hallucinogens and other psychedelics. LSD is lysergic acid derivatives. PCP, phencyclidine. I'm having a hard time because it's a lot of words. It's not because I can't pronounce them. Trust me, it's just a lot of different words to mix together. But PCP is a dissociative anesthetic, also has been known as angel dust at certain times in the past. MDMA, methyldioxide methamphetamine, I can say that one, is the most popular psychedelic in the 1990s. Its perception-altering properties. It is considered to be a drug that was used in psychotherapy for couples counseling and people with chronic diseases. Psychological dependency, no tolerance or withdrawal to hallucinogens. However, they can be quite the trip, bad trip, good trip, the trip, a bad trip on a hallucinogen can be long-term, and someone can have what's called a flashback many years later. Opiates are derived from opium. They include morphine, heroin, which is highly addictive, intravenous injections, snorting and smoking, methadone and buprenorphine to treat addiction, and then Oxycontin, which is known as hillbilly heroin. Here's some useful websites: AA.org, Al-Anon.org, Narcotics Anonymous, NA.org, and Center for Substance Abuse Treatment, SAMHSA.gov. Definitely recommend that you go to SAMHSA.gov and look up the TIP, Treatment Improvement Protocols, and the TAP for your knowledge assessment and skills. You'll be using that quite frequently through your internship and practicums. I'll see you in class soon. Thanks.